There is no class on Tuesday, and then we'll take the test next Thursday. The test review. So the first thing, I gave you the test work page. There wasn't any changes. It's good. On the first question, I know we usually just skip past this one. It's just a reminder to do the test work page, but the calculator is right there, so I'd go ahead and open it. The one you need to do. That's the only one you're going to need for the test. The other ones I've worked out so you don't have to do one of those crazy calculators. I try to make it more like what you would actually do in real life. So number 2 is on our test work page. To pay for a $15,900 fishing boat, Lisa made a down payment of $3,600 and took out a loan for the rest. On the loan, she paid a monthly payment of $221.05 for 5 years. $221.02, I guess. Let me go back. Hold on. I deleted those and I don't really want to. All right. So we can do all this work on our test work page. It was $221. I guess this is part A. Why is it doing that? $221.02. It said for 5 years. So we need to do times 12 for that because that's a monthly payment. Okay, so 12 months. And then we need to do times 5 for 5 years. Well, I mean, you can do it times 60 if you want to, but you could just do times 12 times 5 and do it separate. That's fine too. So I'm going to go 221. Oh, no, clear. 221.02 times 5 times 12 is 13,261. Okay, let me go back and look at the problem real quick here. But she also made a down payment of $3,600. So do not forget that. So we need to add that to the total cost paid. So the payments, we're paying that $13,200, but we also paid $3,000 on our down payment. So the total amount paid is $16,861.20. Okay. So that's your answer to part A. And then part B, go back and look at that real quick. It says, how much interest did Lisa pay on the loan? Well, if it costs $15,900, you can subtract that. And that tells you that Lisa paid $961.20. And that would be the answer to part B. Okay. So just take that step by step. That is, I tried to pick ones where you didn't have to do crazy calculator stuff. You on this one, like you do have to do the monthly payments times there. I told you that it is very important in real life that you always find the total amount paid. So that's very easy to do. You just take your monthly payment times how many months and how many years you have there. And then you can compare that to how much it actually costs to see how much interest you are paying. Of course, you can find a calculator online to do that, but I have my 8 a.m., a couple of questions from the 8 a.m. up there as well. That is on test work page. Okay. The next problem, this is also on the test work page. It says show your work using the formula I equals PRT. So Jessica opened a savings account with $9,000 and was paid simple interest at an annual rate of 4%. When Jessica closed the account, she was paid $14.40 in interest. How long was the account open? So when you do this question on the test, you could have to find any of the variables. I'm kind of okay if you use the calculator on this one, but I did not put a link on there because I was going to make you do this by hand. But technically, since it is algebra, you can use the simple interest calculator. Just open it before you get in the test. It's on Canvas. So on this one, we need I, P, R, and T. So my interest was $14.40, $9,004. Interest was $14.40. We started with $9,000, and it is 4%. We want to know how long. Okay, so I do give you the formula on the test work page, so you don't have to like memorize that or anything. So that's what's given to me. So I do 14 40 equals 9,000. Oh man, I don't really have enough room right there. 1440, 9,000. My rate is 0.04 and then times T. So I do 9,000 times 0.04. I get 1440 equals 360 T. And then divide by 360. And T equals 1440 divided by 360 is 4. Okay. So that tells you 4 years. So you need 4 years to make $1,440 interest on $9,000 at 4%. So it could, in my last class, it told me to find R. So it will switch. You might have to find R. You might have to find P. You might have to find T. But it's going to be the same setup, basically. Anything on the right side, you multiply them together. The 2 on the right side that you get, you multiply together, and then you divide by the interest divided by that, and it should give you the answer. So you don't really need a calculator, like a website calculator for that one. I'm going to go ahead and scroll down and talk about part C while I'm right here. This is definitely in your own terms, like I didn't word it very well, but it says, in your own words, write a simpler compound interest is better and why, okay? So if you're investing, compound interest is better because after the first year, your new interest is compounded. Your new interest is compounded as well. Sorry, I couldn't read my handwriting there. Your new interest is compounded as well. So because after the first year, your new interest is compounded as well. So like in simple interest, you always go back to the principal. We'll see that when we do the problem, but you only compound on your principal. Okay, with compounded interest, you compound your principal plus your interest. So then the second year would be your principal plus your interest plus your interest. If it's a loan, the black part down there, you definitely don't have to write that. Just write something that tells me that you understand that compounding means that you're compounding your principal plus your interest, for as simple as you're just compounding your principal. But if it's a loan, compounding is worse because it makes it add up faster. It makes the interest add up faster. You definitely don't have to do this, but like this is kind of what the problem looks like if you wanted to make a chart. Simple and compound. So simple, you just have the principal. After the first year, it's always just a principal because that's all you have in there. But then the second and third year, you're still just finding interest on the principal every time. But on compounding, you'd find the principal plus the interest. And then you'd find the principal on the interest plus the interest plus the interest. Like, you keep adding interest from every year. So, like, whatever helps you, whatever makes sense in your brain, you can't really get that wrong because it's in your own words. But it is just that idea of compounding means that you're compounding your principal plus your interest. Probably the quick way to say it. All right, let's go do that problem real quick. Number 4. Come on. All right, number 4, you got Lisa, simple interest at 2%, $60,000. And Scott deposits $60,000 into an account that also pays 2% interest, okay? So for Lisa, we can go ahead and let's do all the simple interest. That's my first column. Simple interest is principal, $60,000, times rate, 0.02, times time. So after the first year, it is $1,200, okay? You can go back, click undo, and change it to a 2 in the calculator. And it's, oh no, I did $1,299, sorry. $1,200. This would be $2,400. It actually just adds, it's very linear. It just adds $1,200 every year because you are getting 2% on $60,000 every year, okay? So you just add $1,200 every year. For the other one, for the compound, Scott deposits $60,000, same amount, and 2%, same interest rate, but it's compounded annually. So we are going to go over to the compound calculator, and we are going to put, I feel like it needs to refresh. Does it need to refresh? Come on, okay. So you can open this at the beginning. It is on question 1. 2% interest rate. It said compounded annually, and we're doing 1 year. So after I compound 1 year, the only thing I'm compounding the first year is the principal amount. So these numbers are actually going to be exactly the same to start. Okay, they earn the same amount to start. Now if I change that to 2 years, instead of being $2,400, it's actually $2,424. Okay, so compounding annually at 2% gets you an extra $24. Now if I do 3 years, 3672.48. 3672, not 48. So compounding will always get you more after the first year because you're compounding the first year plus any interest that you made. And this is why I said like start early, because the first year you just get your normal amount, but the second year you get an extra $24. The next year you get an extra $50. The next year you get an extra $75. The next year you get an extra $100, and it just keeps going and going. And that's just a 2%. So this is what you would do for this problem, and that chart should help you answer the question, but basically you are compounding your principal and your interest is what I'm looking for on that test work page. Let me write real quick here. This is I equals PRT for the second year, 2,400, just so. And then I'll write use website calculator. All right. Number 5 says to write what you put into the calculator on the test work page. So again, just me making sure that you are putting the stuff in the calculator or the website correctly. Man, I'll have to screenshot it in a second because I need to use a calculator. Okay, a bank offers an investment account with an annual interest rate of 1.18% compounded quarterly. So I'm going to go ahead and put those numbers in. Where's my calculator? On my keyboard. Refresh. Sorry. My keyboard didn't pop up there. There we go. 1.18 compounded quarterly. So click quarterly. What else did it say? Amy invests $4,100 in the account for 2 years. Assuming no withdrawals are made. How much money is in the account after 2 years? How much was it? Sorry, $4,100, 2 years. Lots of calculators on this one, so this test shouldn't be bad once you figure out the calculator. 97.76. So, assuming no withdrawals are made, how much is made? What did I say? 97.76. How much interest? 97.76. The calculator actually tells you both of these numbers. If you had to find it, you just do part A minus 4,100 and do it. But use the calculator. I guess I could say use website compound interest calculator. All right, on the test worksheet, what I want you to do on this one is just write what you put in the calculator. Quick look. So you have 4 numbers or 5 numbers you want to put in. I guess you could write, you don't really have to write this one, but we were trying to figure out our future value. Our initial value was 4,100. Our time was it 2 years? I think. Our rate was 1.18 or percent or 0.018. Like you don't have to write the percent in the decimal, but one or the other. And then our N was the number of times compounded. So that is quarterly or 4. You don't really have to write N because we don't do the formula, but you could just say, you could just also write compounded quarterly. Either way of that is fine. So you're just kind of writing what you put in the calculator. Number 6. I believe it is the website calculator again as well. Initial amount of $3,400 is invested in an account at an interest rate of 5.5% compounded continuously. Find out how much it is after 4 years. Okay, so on this one, 3,400, 4.4. I don't think that's what I said. 5.54 years. But it says compounded continuously. One thing to note right here, just because we're talking about it, and I am letting you use calculators. So the compound interest formula looks like this right here. We don't really do the formula because why? The internet can do it for us. But when I change it to continuously, it does nicely change the formula to that A equals P times E to the RT. Maybe if it ever loads. So you can see the formula did change. Come on, you can do it. The formula did change there. That E is like 2.72, just like pi is 2.14. That E is 2.72, so it's just something that's used a lot in finance. So there are your numbers to the problem. Should be pretty easily, or I guess what's the question, I guess. How much, find the amount after 4 years. So my answer is a 4236.66, right? Okay. 4236. Just in case you go back, let me make sure. Oh man. Use website calculator. And that's the key word there, is that continuously. Number 7 is on our test work page. Number 7, to help her child with the college fund, Jenny needs to invest, assuming interest rate of 2.25% compounded annually. How much would she have to invest to have $94,000 after 13 years? So on this one, we want to figure out our total amount. Okay, so I'm going to switch the drop-down menu right here. This website is being slow. I hope it is not slow for you tomorrow, although Alex is kind of being slow too, so it's probably just my iPad. 94,000. Apple just came out with a new iPad, so they intentionally slow down this iPad to make sure that I go buy the new one. 2.25, and then it says compounded annually, 13 years. So just like the other problem, I want you to write what each letter is there. 761364. 761364. All right, so the crazy are I see that and I'm like, well, who's going to invest $70,000 and just set it aside for 13 years? That's kind of crazy numbers there. But the point of this and the compounding interest is that she puts $70,000 in, and then 13 years later she gets an extra $24,000 for free. That's kind of the point there. So again, use website calculator, and on this one you got to make sure change drop down to find P, because you're trying to find the starting amount. So what we want to do on our test work page, my goodness. On our test work page, we are going to do A, we want 94,300. P, we don't know our starting amount. Our rate was, what was it? 2.25 annually. 2.25. My time was 13. That's percent, so 0.0225. 13 years. And my N was compounded annually. So that is 1. I'm fine if you just write compounded annually, because that's the way the calculator really does it. But again, you're just kind of writing what the inputs are for the calculator there, and that should help you decipher the difference between numbers 5 and number 7, right? Because number 5, you're just trying to find the end amount, but number 7, you're trying to find the starting amount. So that tells you to remind you to change the drop-down menu. I try to make these test work pages so they're not useless, but they kind of help you through the problems a little bit. All right. Next one's on the test work page as well. I'll come right back to this in just a second. I want to see what the next one was. All right, on let's see if I can, it's a lot easier for you when you have a paper and a computer in front of you. 662, 90, 549, 29, 1.82. That's purchase. Okay. All right. So to do this on the test work page, we have the documentations right there. So an unpaid balance at the end of February. You got a purchase in March and a payment. In March as well. Suppose the credit card company charges 1.82% monthly interest on the unpaid balance from February. So that's the first thing we do for the unpaid balance in February. At the end of February, our initial account was 234.7.95, or was it 7.5? Looks like a 7, kind of. Yes. We want to figure out how much interest we're getting charged on that, so we are going to charge 0.182. So 2347.75 times 0.0182 is $42.73. So that is my answer to part A. That's really all I need to write on my sheet here. But just go ahead and do part B. The part B says, what is your ending balance at the end of March? Well, if it was $2347.75, and then I got added $42 interest, and then I made $662.96 purchases, but then I also made a payment of $549.29. What you have to do right here is basically figure out what to add and subtract. So my original balance was $2347.75. I add my interest. I add the purchases I made, and I subtract any payments I made. So this should be $2504.09. That would be my answer to part B. All I ask is that you show your work for part A, but just so I have everything right there in one spot, you can see it. And that is what happens with credit card payments. It's like, oh, okay, I got a little balance, that's fine. I only spent about $600 this month. You just don't really look at it. You say, I spent about $600 this month, so I'll make about a $600 payment. Well, then all of a sudden you went from $2,300 to $2,500 because you got the interest plus any difference in payments and purchases, and it just keeps adding up little by little, little by little when you don't pay it off. All right, the last 4 problems should be easy. These are the ones that have the Alex loan calculator in it. So hopefully you can get these right. But 11,500. So comparing 2 loans, for A, the interest rate is 6.25 for 9 years. So we calculate the monthly payment is $139.49. Okay. For loan B, it is for 7 years at 6.1% interest. And the monthly payment is $168.55. Okay. So loan B or loan A is going to be lower because it is 9-year loan, and loan B is only a 7-year loan. Okay. And what you have to do is subtract these. 2906. So you have to decide in your real life, is it worth having a loan that is 2 years longer? Is that $30 a month worth having a loan that's 2 years longer, which means a bunch more interest and different things like that? So that one, you just find the monthly payment. The next one, I want to take out $110,000 Make sure I put the right amount of zeros in there. Interest rate of 4.75 for 30 years. Okay. So the monthly payment is $573.81. The total amount to pay the loan would be $573. I guess I can do that on the screen right here. $573.81 times 12 months. Oops, times 12, not times 12 months for 30 years. So that would be 206,571.6. Find the amount of interest paid. Okay, well, that's how much payment they made, but the home loan was only $110,000, so actually paid $96,571.60 in interest. $96,571.60 in interest. Okay, I forgot to screenshot the last problem, didn't I? I don't think y'all will have too much problem with these, but we'll make sure it's on the review page for you. So the only thing you do here is part C is 168.55 minus 139.49. That equaled 29.06. And that one is lower, right? Come on. And then part 10, or number 10. Did it take away my numbers? 30. Oh man, that calculator's taking up all the space. You know what, sorry. All right, so there's part A. Part B was 573.81 times 12 months times 30 years. So that equals 206,571.60. And then part C was minus 110,000 is 96,571. That's part C. Okay. All right, number 11, same idea with this one of these calculators. So we are going to do 15,500. Loan term for the first loan was 8 years with a 6.1. So we could calculate. Now, what's different on this one is it does say to find the total amount. So don't think it's just a monthly payment. This one wants you to find the total amount. So 204.25. I'm sorry, 45. Times 12 for the months times 8 for the years is 19,627.2. For B, it is 4 years at 6.25. So it is 365.80 times 12 months times 4 years is 17,558.6.4. So which loan would you pay less? You are going to pay less with loan B. Because 19,627.2 minus that would be, you'd pay $2,000 less. So this is what I told you. Anytime you do a loan in real life, you always want to figure out the total amount that you pay for it. Okay? You want to figure out the total amount that you pay for it because that is going to make sure that you aren't just paying a bunch of interest on something. So on this one, part B, you pay $2,000 more interest. Okay? So right here, this was part C. For part A, oh no, we don't have that number anymore. part B was 365.80 times 4 times 12. Can we figure out that number working backwards? 1967.2 times. Nobody wrote down that number, did they? No, y'all zoned out a long time ago. I'm just up here talking to myself. I know what it is. I think it's 204.45. That's right, yeah. 204.45 times 8. Well, times 8 for the year, times 12 for the months. I kind of like writing that backwards, though. I did it down here, too. Times 12 months, 4 years, 12 months. This one was 4. This one was 8. All right. And the last one is the periodic calculator. The periodic calculator, monthly deposit, we're going to put $85 in, number of years. Well, we're going to do 1 year to start. No, we're doing 15 years to start. At 3.5% interest, okay? So we calculate, we have, after the first year, we have 20,084. We have $20,000. So then we're going to do 30 years, okay? Click calculate. Now we're at $54,000. Now we're going to do 45 years. Calculate. And you have $111,000, okay? This is why I talked about investing early. So when you first start your first 15 years, if I only would save for my retirement for $85 a month at 3.5% interest, if I didn't start until I was 50, I'd only have $20,000 by the time I was 60, okay? But if I started when I was 35, I had $54,000. So the way we're going to find this is 54,010 minus 20,084. So during that second 15-year period, not only did we get our original interest, which was $20,000, but we got an extra like $13,000 on top of that, okay? And then to find the other one during our last 15 years, 54,010, you just subtract those. We got 57,306. So you get $20,000 worth of interest for the 15 years, but then you're making interest on interest for the next 15 years. You get $33,000 worth of interest, and for the next 15 years, you get $57,000 worth of interest. This is where putting like a little bit of money in. So the amount of the amount in the account did not grow faster over time. That is false. There's more money deposited. Nope, I never changed. I always just put $85 a month away for all 45 years. So the amount was the same for every period. The amount earned more interest in period 2 than 1. Yes, every period will earn more interest as you are going throughout there because you are putting interest on top of your interest, okay? This is why it makes such a big difference than retiring for or saving for retirement for 15 years versus 30 versus 45. You get an extra $13,000, then an extra, I don't know, what is that, $24,000? All right, so for this one we did, what was it, 54,010 minus 20,084, and this one we do 11316 minus 54,010. Okay. All right, so that is the review for the test.